Hello and welcome to the AI Research Roundup. I'm your host Alex, and today we're diving into some fascinating AI research. We'll be looking at a paper titled R1VL Learning to Reason with Multimodal Large Language Models via Stepwise Group Relative Policy Optimization. Now, the core idea here is about improving how these big AI models, especially those that handle different types of data like images and text, learn to reason. Currently, many models learn by just, imitating successful reasoning steps from examples. This paper introduces a new way, called StepGRPO, which uses reinforcement learning to help the models understand the reasoning process itself, not just copy the right answers. It uses specific rewards to encourage following logical steps. Right, and figure 1 here gives us a nice visual of this comparison. It plots performance, specifically reward and accuracy, against the number of training steps. You can see the solid lines representing their method, StepGRPO. They show both reward and accuracy steadily improving as training progresses. Now, compare that to the dashed lines for the standard GRPO method using just outcome-level rewards. The accuracy actually trends downward over time, and the reward is lower and less stable. This really drives home the point about sparse rewards hindering learning, while StepGRPO seems to provide a more stable path to improvement. So building on what we saw in Figure 1, where StepGRPO showed that steady improvement, Figure 2 here gives us a look under the hood at the framework itself. It shows the two main phases, a warm-up phase to get the model started, and then the stepwise optimization. The key thing here is that for a question, the model generates a group of different reasoning paths. Then these paths are evaluated using two new reward types, StepRAR and StepRVR, which look at both the accuracy of the intermediate steps and the logical structure of the reasoning. This helps calculate which paths in the group are better. So we just talked about the warm-up and those two reward types, StepRAR and StepRVR. Table 2 here really breaks down how much each part helps, specifically looking at performance on the MathVista benchmark. You see the warm-up alone boosts the score quite a bit over the baseline. Then, adding either StepRAR for intermediate accuracy or StepRVR for logical structure improves things even more. But, the best performance, 63.5%, comes when you combine the warm-up with both reward types. This really validates that both StepRAR and StepRVR are important parts of the StepGRPO approach. So we saw how the different parts of StepGRPO contribute. Now, Table 1 here shows the payoff when you put it all together. It compares our models, R1VL, against a whole range of others across several benchmarks. Look at the R1VL 7B row near the bottom. It gets an average score of 57.1% across these tasks. That's a noticeable improvement over the base Q&2VL7B, and also better than using standard GRPO, and on MathVista specifically. R1VL7B scores 63.5%, which is really competitive performance. So yeah, this confirms StepGRPO leads to solid gains. So we've seen the overall benchmark results in Table 1, showing R1VL's strength. Figure 3 now zooms in on the MathVista benchmark again and directly compares our StepGRPO method against standard supervised fine-tuning, or SFT. Similar to Figure 1, we see accuracy plotted against training steps. The orange line, representing StepGRPO, consistently stays above the blue line for SFT. Both improve with more training, but StepGRPO reaches a higher accuracy level, showing it's a more effective learning strategy than just SFT alone for this kind of complex reasoning task. So we just saw in Figure 3 how StepGRPO outperforms standard fine-tuning on MathVista. Now Table 4 digs a little deeper into why StepGRPO works better, again using the MathVista benchmark. It compares using just the warm-up phase, which gets 61.7% accuracy, versus adding outcome-level rewards, which bumps it to 62.3%. But look, adding the stepwise rewards, which is their main contribution, pushes the accuracy to 63.5%. This really shows that rewarding the intermediate steps is more effective than just rewarding the final answer. Okay, so we just saw the numbers in Table 4, showing that stepwise rewards really boost accuracy. Figure 4 gives us a more, well, a visual feel for why that is. It shows how different models tackle the same math question involving objects in an image. You can see the baseline QN2 model and another one called Mulberry 7B. They make mistakes in their reasoning steps, like misidentifying objects or counting incorrectly. But the R1VL model, using StepGRPO, follows the steps correctly, identifies the right objects, and gets the right answer. It really shows how rewarding those intermediate steps leads to a more reliable reasoning process. So yeah, those examples in Figure 4 really drive home the point. This R1VL model trained with StepGRPO, well, it shows a clear improvement in multimodal reasoning, largely thanks to focusing on rewarding those intermediate steps. Getting AI to reason reliably step by step is crucial for tackling more complex real-world problems. That's all for this episode of the AI Research Roundup. Thanks for tuning in. I'm your host, Alex, and I'll catch you next time.